basically, this is going to focus on something called Emsrv. Basically, it's the server component of our Envy developer system. And so if you're not familiar with that, it's basically a highly integrated system into VAST that handles everything from configuration management to version control, user authentication. It's got a repository, source code repository. You can use it as a sort of a centralized connection. You basically a centralized repository that you connect to, which is kind of what we're going to focus on today. But you can also use it as more of a, in kind of in a way like a Git, like a distributed version control system, which is actually how a lot of us at the company use it, which is basically committing locally to a local repository, and then we have various tools to help us reconcile between remote and local repositories. So that's a little bit about that. So Emsrv essentially is something that a lot of our customers use that handles that centralized repository model where there's a lot of folks connecting to it, and so we were modernizing that piece, and so that's what we're talking about today. And specifically, we're going to focus in on sort of the security aspects from the last presentation. You can guess why that might be important to us. Modularity and performance, and then of course with an eye of basically future-proofing it for many years to come. So this is a critical modernization effort for us, and the improvements we're making will not only strengthen the systems today, but also ensure that we have some of our important future goals handled. So I'm going to be sharing details about the architectural evolution of Emsrv, how that evolution has been carried out, and how the results will benefit both the developers and the businesses when we get to the point where we'll be releasing this. And as I said a little earlier, what I'll try to do, which is a little different from the last time I did this, where I can think about it, I'll try to describe how AI tooling helped in various facets. Some are interesting, I think, just because there's so many different ways you can make use of generative AI and prompting and that kind of stuff that it might be interesting to hear about just some of the ways of which it was used. Okay, so here's what we'll be covering specifically. First, we'll start by discussing the goals that were driving this effort. Next, we'll sort of look at how the Emsrv architecture has changed, and I'll walk you through the current architecture, the challenges we face with it, and then a look at the new architecture that was designed, which makes it far easier to adapt to future needs. Then I'll walk you through the specific steps that we used to transition from the current system to the future one. And finally, after that, we'll explore our roadmap for Emsrv, highlighting sort of key initiatives that we plan to implement. Finally, of course, if you have any questions, feel free. Okay, so before we dive into the specifics of how we were evolving Emsrv, let's just take a step back and look at the big picture of why we're doing this. So the core goal is driving the modernization effort. And so let's take a closer look at each one of these goals and how they sort of guided our approach. So the first goal was basically we're focused on enhancing security by addressing potential vulnerabilities in the code base and providing really badly needed at this point security to our communications architecture. Emsrv was developed by various folks, OTI and IBM back in the it's been around for a long time, and it sort of so the security landscape has changed so much that we wanted to make sure that the connection ability to the central repository was really beefed up in terms of what it could provide in the security space, as well as the traffic that was going back and forth. And so we'll talk about that. Just so you know, most people don't use it in a WAN kind of scenario. In fact, we'll discuss why that's problematic. And so having it be local within the shops, it's not like it's normally used where unencrypted traffic is just going around the world. It really was designed for local teams, and we want to open that up a little bit. Next, we'll introduce modularity how we introduced modularity to break the system up into smaller independent modules, which makes the code base far more scalable and easier to maintain and implement new features. So we're also bringing many performance analysis tools to bear on the code itself, making those incremental improvements along the way. However, we're also designing necessary extensions to Env that can be used to create better remote server performance. And another critical goal is the undervalued goal is improving documentation. We're providing detailed, comprehensive developer documentation for all modules, making the system more transparent and easier to understand for new developers that work with the code bases. Now, it's an ongoing theme that I know I've discussed many times over, and here's another place where it's showing up. We're looking at the system and the care of that system and those teams over the long term. So this exercise alone has given us even more intimate knowledge of the system by doing that, and new ideas on exactly how we could extend it. So sometimes it's the smaller, undervalued things that make the big difference, right? I said earlier about the way we learn. You know, we talked about the podcast generation piece. We talked about how if I simply write something down, how much that makes it into your head easier than just typing it. This is yet another thing. The act of doing the documentation created new ideas and better understanding even for the existing team. Finally, we're also focused on establishing a robust testing framework that will ensure, you know, the system stability and prevent regressions, which we were extremely concerned about. I mean, this is, after all, 10 to 15 years worth of code base and for our customers in a repository. The last thing we want to come in and do is have a nifty update that corrupts their databases. So this is a critical area to make sure that we are doing due diligence on making sure every time we make, you know, these forward changes that we're doing them in a way that's safe, and we're testing, we're following good practices here. Okay, so these goals are the foundation. You know, we need to implement these future enhancements, which I'll cover in more detail. Okay, so we covered the goals driving our modernization effort. So now let's kind of dive in and focus on how we're updating the architecture to make it easier to manage and better suited for our future needs. Okay, so the architecture that we deploy today in the Emsrv project is really based around 3 components built on top of a standard C runtime. So these components are mostly, you know, self-contained. They don't share code with one another, and they don't have any third-party dependencies. So while they're stable, and they are, the lack of shared code and sort of limited modularity makes updating and scaling these difficult. One example would be, you see the 3 different pieces there. Each one of those has their own socket implementation. And each one of those socket implementations is not a copy of the other. It's just some subset of each, whatever they needed for that particular module, and then of course, you know, formatted completely differently. And it's not a complaint. I think it's just a natural thing that arises when you have something that's been around for a long time with a lot of different folks and groups touching it. And of course, you have business demands and timing and those kinds of things and pressures that can create situations like that. Okay, so the first one is, the first one of these components is emadmin. So this is a command line tool used to manage and control the Env developer server environment. So it handles tasks like repository management, user access, configuration, version control. When this component is built, it generally creates the command line tool that folks know who use VAST called emadmin. Emprims, this is a component that provides the low-level functionality that allows Smalltalk to interact with the Env repository, which we'll talk more about. So this can happen in 2 ways, directly through file I/O, or indirectly via socket connection to Emsrv. This is basically a socket server. And when built, this component builds 2 shared libraries, the file I/O and the socket client libraries, that Smalltalk images call out to, when performing Envy-related operations. Finally, Emsrv is the central server that coordinates operations for teams using Envy Developer. It acts as a socket server, handling the Envy protocol and facilitating shared access to the repository. So when this was built, you get what you might expect, a program called Emsrv. And I should mention again that this has been a very stable architecture over the years. And the point of this presentation isn't to make the point that there's something particularly wrong with the current architecture, given what it was designed to do. But like any code base, over time, we have to keep it up to date with the latest in security standards, implement new facilities for improving performance, and make sure it's in a good place to implement new features that were perhaps outside of the scope of the original design. Okay. Clearly, I missed my cues for, okay, there we go. Okay, so this slide highlights the re-architected Emsrv code base. So this is based on 3 key principles. First is modularity. We've split the code into smaller independent modules, making it easier to maintain, update, and scale as needed. We have well-defined, strict interfaces between modules, ensuring that changes in one area don't affect others, improving the overall system stability and reliability. And finally, rather than hard coding components, we use sort of a pluggable framework. This allows us to easily swap out different implementations or backends as needed, providing the flexibility to adapt more quickly to these new requirements. So this new architecture makes Emsrv more adaptable and ready for sort of these future enhancements without the need to do a complete system overhaul, which really isn't our primary goal at this point. We just want to get it in a really good place to continue to move forward and solve some interesting pieces like security and performance along the way. Okay, so now we've covered the current and future architecture. Let's focus on the specific steps we've been taking to make this evolution a reality. I don't know if you'll be able to see this. I mean, it's probably okay. Okay, so our first major step in modernizing the Emsrv project was switching to a build system generator, specifically CMake. So this decision provided several key benefits. CMake gives us a single source of truth for the build process, eliminating inconsistencies across platforms and environments, and it ensures everyone builds the system the same way, making it more reliable. We also enforcing modularity. CMake helps us break the code base into smaller independent modules with clear dependencies between them, and this is sort of critical for our long-term goals. I don't know if you can see it in here, so I'll try to weave in the AI piece in this. So we use CMake for our VM project, and so Emsrv was sort of retrofitted with our CMake build system from the VM. Now those are older CMake scripts. There have been some newer calls in CMake that were created at later versions that actually really facilitate modular programming a lot better. It handles sort of transitive dependencies between what you could call modules. They help glue things together and build things more easily. This was actually pointed out in one kind of conversation and prompting with ChatGPT. And essentially, after feeding it enough of the existing, getting to the place where I was happy with, one of the scripts, and then feeding it what all the other scripts look like, it was pretty quickly able to get me to a place where they all were updated and commented. So those comments are primarily generated comments. And of course, I'm overlooking them, making sure that it all makes sense. But it's just a lot of that busy work and making sure everything was unified and those kinds of things. It really helped with that piece. And here, I mean, we talked earlier about the profound things in life are maybe the things that should be kept with the humans. This isn't profound. This is basically a prescription of here's the best practice. It's everywhere, and so help me generate the appropriate scripts. So I feel like it's a good use case for AI. CMake's cross-platform, and so it really as well as cross-build it provides different build systems pretty easily. And basically, it allowed us to do more incremental refactoring of the code base. And so that it's been, and again, we're all familiar with this internally because it's what we use for our VM builds. Okay, so next we've got tests. Yeah, this one was very interesting from an AI perspective. So, okay, so before making any major changes to the Emsrv code base, we needed a structured approach to ensure stability. So since Emsrv has been stable for so many years, we wanted to maintain that reliability, by confidently, modernizing the code without introducing regressions. So we adopted sort of a test-driven development plan, which included basically a C unit testing module. So we developed a custom C unit testing module inspired by S unit from Smalltalk. It includes sort of advanced assertion capabilities, such as timer-based and tolerance level assertions, to ensure precise and thorough testing of values, something more necessary for maybe a language like C. We integrated this module with C-Test, which is part of the CMake ecosystem, to run automated test suites as part of the CMake build process. So this allows us for easy integration into CI pipelines. So every change is validated during the build, giving us confidence that we're not introducing regressions. Finally, since Emsrv operates in a client-server environment, we developed a thread module to help with simulating the Envy client-server interactions by using native threads, mutexes, conditional waits inside of unit tests. So by implementing sort of TDD with the modules, we build a solid foundation to modernize the code base safely. It before did not have really any tests at this level. So from the AI story, I got it to a place where, so this test you see here is generated. So this was generated by ChatGPT. So it knew enough about the code base to get it to that point. So it's a nice looking test. The place where I found that it wasn't, it was okay, but it wasn't great, was where the test involved maybe a server thread, something external. Like it needed to set up a server thread, and that lived in a different function that was down in the file somewhere. And sort of the scoping was outside the scope. Rather, this scope is very limited, kind of like the local variable, right? It's very, open a socket and do this thing and then close it and then you're good. Not a start up a server and then it's off doing its own thing somewhere else. It wasn't, at least I didn't get it to the point where it was extremely useful, so that was just something that, I got it to the point where I set up the server and client threads, and then it could take over. Okay, we also integrated Oxygen along with it, with CMake as well, so it generates the documentation. As part, basically, we just, like I said, it's undervalued to do these kinds of activities by some teams, but I think it's, was really important to be able to, fully document each module. So we feel like, through the process, it improves code clarity, provides valuable resources for future developers, and so I think it's a pretty good thing. So here, documentation of the of functions, of C functions, was something that was done a lot. It helped me personally, not just from make sure that here's a function, now tell me what you think this function does and do it in this format, which is the real thing, right? I need Doxygen tags. Here's sort of my template for Doxygen tags in format. Now go ahead and generate me something. Even if the comment wasn't perfect, I could go modify it to to a place where I was more comfortable with it. But it ended up, I'm not a full-time developer, so, everybody's time is precious, but I have limited time with regards to some of this stuff. So these kinds of tools and activity really saved a lot of time for me. So security has been a key focus of our modernization efforts. We've implemented several critical enhancements, the most important being the integration of SSL TLS for secure communications between Emsrv and its clients. So we've introduced SSL TLS to provide encrypted communications. We've also made this flexible by introducing custom security parameters that you would expect today, certificate management, protocol negotiation between client and server. We actually have the concept now of an Emsrv version. So the client and the server can actually negotiate which version of the Envy protocol that they are going to be operating off of. And so we actually use ALPN protocols, which is that piece where it decides which version of the Envy protocol it's going to use is done during the SSL TLS handshake. So it's very fast. We've got, it's basically all the ciphers and peer verifications. Security scanning, we've performed, very comprehensive security scan on to identify any vulnerabilities, particularly in the code base and the communications architecture. And so this helped us reinforce security in areas like memory management and secure communications. We've also improved memory management to ensure that memory is allocated and deallocated securely, preventing issues like buffer overflows and memory leaks. So our approach to managing the repository has evolved significantly as part of the Emsrv modernization. A key change is the introduction of a pluggable backend architecture, which allows us to support multiple storage solutions. So traditionally, the Envy repository is a big giant flat file that really begins with a repository header and followed by a sort of table of contents like thingy, and then just a bunch of records. And the records represent all sorts of the configuration management pieces of Smalltalk, like configuration maps and applications and classes and methods and users and all those kinds of things. So this is, the traditional version, but we've also provided sort of a backend for SQLite, which has features like transactional support and data integrity. That could make it a better choice in certain scenarios. Additional storage types can open the door for more advanced security mechanisms for protecting data at rest. And the backend system is extensible, meaning we can easily add new storage solutions as the system evolves. With the upcoming schema module, we'll be able to introduce even more flexible storage options. And so this modular kind of pluggable architecture is key to making Emsrv more flexible and kind of future-proofed. We've made significant improvements to Emsrv's client-server communications, including the introduction of the new IPC module and support for protocol version negotiation. So essentially, the IPC module encapsulates all client-server communications, managing different protocol backends, and so this sort of provides a much nicer and safer way to, and allows us to be able to extend the protocol for future needs. As I sort of mentioned before, we have this protocol version negotiation. We need to do it in a way that ensured compatibility. So basically, because in a given central repository, you could have vast clients from all different, vast version 7 and version 11. They can all basically connect and manage code with each other. So based on what version they're on, they might need to negotiate a different version of the protocol. So we're also evaluating extensions to the Envy protocol to support wide area network scenarios. So our goal is to make Emsrv in WAN scenarios an actual viable option. And so as part of our modernization efforts, we've introduced the new schema module to bring structure to client-server communications. So essentially, this new schema module is responsible for organizing the data and communications, transforming what was previously just an uninterpreted stream of bytes between the client and server into structured, well-defined data. So backing up for a moment, in VAST, the schema, or all those records and how those are laid out, is actually defined on the client side. Emsrv itself in the backend repository, it has no idea what it's storing. It doesn't know it's actually storing Smalltalk code at all, and in fact, it stores objects as well. And this is one of the reasons why Emsrv was also used in IBM Visual Age for Java. So there was a whole Java schema that was being stored in an NV repository, so a set of Java-style records. And so it's a very powerful thing, but the problem there is when it all gets reduced down to these calls to Emsrv, it's just a bunch of uninterpreted bytes with indexes and things. It's because it literally has no information of the schema. That's it lives in the client, so that's okay. But now you can't make sense of that data, and maybe there's interesting things we could do with that data if we knew how to interpret it down at the Emsrv level. And so that's something that we've begun to really push harder on that, so we can actually understand the data that's coming in on the server side. Okay, so we're traditionally, as I've said, that lives Smalltalk image side, and we're kind of porting that now to the server side. And so having a schema in place sets the stage for future enhancements. Once communication is structured, Emsrv will be able to conduct more advanced analysis on the data being exchanged. So this opens the door to insights, performance optimizations, and potentially new features based on a better understanding of the data and the exchanges with that data. Okay, and then we have, coming near the end here, we've got a new compression module. This is basically, the way that we compress source code. Basically, the big deal, the nice thing here is there was a specific compression scheme that was only for the Smalltalk code itself, and it was sort of, heuristic-based compression, which does a fine job. But again, you can store gigabyte byte arrays if you want. Not that that's a great idea, but you can do that into the NV repository. You can store all sorts of binary data. There's nothing stopping you from doing that. It's really that flexible, but it doesn't know how to store that efficiently. So you imagine if you had a zeroed out gigabyte byte array, well, in the NV repository now, it's going to take a gigabyte, which doesn't, in that particular case, would certainly not need to be the case with better compression schemes. So as a result, we've implemented user-defined, basically bindings to LZ4, Z-standard, Brotli, and zlib, which coincidentally happen to be the DLLs we ship with our product because that's what VAST works with. And so it'll just allow, a lot better compression of these libraries. Okay, so looking ahead, just to be clear, everything we've talked about now is sort of in our development branch, the result of ongoing, development we've been doing, again, as time allows for me, but I'm trying to get, and this is the documentation piece and some others, and getting it nicely organized. I'm trying to get it to the point where more folks are going to be involved in this, and it all just doesn't live, in my head. And so we have a lot of initiatives that we're looking forward to with regards to analysis at the repository level. And a lot of these are being made feasible now that these modernization efforts are taking place. So, as I said, we're working on those WAN extensions, being able to use NV in a wider range, and of course, you have to have security at that point. And we're also looking at, various other things related to security. Digital signatures, encryption of various data, and repositories themselves. New ways to represent the repositories, like SQLite databases and others. Also, as we said, looking at new analytics that are going to be available for NV repositories. And so this is sort of the roadmap where we're headed with these, and I think it'll be pretty exciting when it does land. The first to come out will be the SSL TLS because that is complete. And while it won't make the next release, it'll make the following. And of course, by that point, we'll have a lot more ready to share and know that it's going in. Okay, so that brings us to the end. Thanks for your time. And if you have any questions, let me know. Thank you. Great.
So for sure you thought about this, but I wanted to ask you this. So how big is Emsrv? How many lines of code? Is it
Lines of code?
yeah, I mean, is it a big application? Is it medium size?
Well, I wouldn't say it's not a big it's not a big application. Um, and of course, we now have it to the point where before it was there was no way to, let's say your goal was to get it written in Smalltalk, or let's say your goal was to get it in Rust, or whatever the
No,
case.
no, it's small talk. I mean, because you did a lot of effort. I think you.
This isn't
you,
actually, well, so the effort is really in the untanglement
Okay.
piece. And it's too dangerous, I felt, or I'm not good enough to do it,
Okay.
to basically take what's there and pump that into Smalltalk in a way that we'd be ready to go. There's some obscure pieces in there
Okay.
that's required some software archaeology, some understanding. This whole documentation. There's a lot of goals here that are going to bring us to those questions. So I think we'll be in a place where, I mean, somebody asked at the VAST Summit, you guys work with Rust a lot. Have you thought about putting it in Rust? And yeah, I've thought about it.
Yeah.
But this one was more of now we got to get it in a place where, it's ready to have that kind of, we have the knowledge for ourselves. We have that in a place where we can carry that over time. And really, at the end of the day, it's not a complete, as I kind of said, it's not a complete re-architecting. And this is like, the only reason it's taking time is because I have limited time.
Okay.
But we're trying to get it to a place where it's not just me. And that's, part
Okay.
of this as well. Yeah.
Okay. Thank you.
Good question. Thank you.
Okay. Thank you. I
Thanks.
think. Oh.